Today's lesson looks at the sine law again, but it looks at the ambiguous case of the sine law. The definition of ambiguous means open to interpretation or duplicate solutions. So we want to look at an example of today how you could get two different triangles with the same information. And ultimately, you have to decide, are there going to be, given the information, are there going to be two triangles, one triangle, or in fact, no possible triangles? So given this picture below, and again, the dashed line is supposed to illustrate something. We're going to see that in a sec. Using this triangle below, if we knew this information, if we knew angle C, if we knew AB, also little c, if we knew AC, in this case little b, then here's what happens. This is an SSA triangle, meaning side-side angle. And the given angle is an acute angle, less than 90 degrees. And if the height of the triangle is shorter than both sides, like when I say if in this example, it is a given. So this is what we mean. The height h is less than both the given lines, so line C and line B, then what can happen is you can get two possible triangles. You can imagine swinging that solid line AB to the other side of the height, to the dashed line. And this is this idea of an ambiguous case. You don't actually, or you may not know which triangle is actually drawn, or which triangle to draw, or which triangle you're actually asked to answer. And in that case, you have to be ready to deal with both of the possible solutions. So these two examples right here, case number one is the solid triangle above. So it's A to B1. So in this one right here, this would be this one, B1. Now in case number two, it would be the other triangle that you could draw, and it would be absolutely the same information. You'd know little b, you'd know little c, you'd know angle C, and this one right here is this idea of, say that side AB swung to the other side of my green highlighter line, which is the height. So what we want to highlight is that when you are given certain information, there are two possible solutions, and we need to be aware of that. And sometimes the two possible solutions are what you're going to have to find, and sometimes you are going to toss out one of the triangles based on information given. So here's an example, and again, if you look in the textbook, you're going to get this complicated explanation of symbols and language, and the best way around it is to simply draw the picture. So here's what we have. We have a triangle ABC, and we're given an angle, and we're given the side opposite, and we're given another side. And what we're going to do is we're going to construct it the same way each time. But we're going to ask ourselves a question. So in the first picture I'm just going to draw the 30 degrees. So here's our 30 degrees. Here's angle C right here, and it's 30 degrees. And our angle B is going to be over here. And that's important because little b is 42, so that's going to be right there. And then we're going to have little c, the side opposite, and it's 42. Now, I'm not going to draw that right now. I'm just going to imagine this picture, and this is the picture we always want to draw right now. And what we're going to do is, the first thing in deciding how many possible triangles we can have is we are going to figure out the height of this triangle right here, just given the information that we have. So this is a picture that looks like case number one above. And in figuring out how big h is, then I can go ahead and look at little c, and I can make a physical interpretation. I can imagine swinging that side to the right or to the left. So in figuring out what h is, well, again, I'm going to label it h. The sine of 30 degrees is equal to the opposite over the hypotenuse. And when we go ahead and we solve that, we get h is equal to 21. So here's what's important. Given that h is 21 and it is smaller than 24, what I can imagine is I can imagine that other side of my triangle is over there. Again, I'm gonna talk more about this when I see you, but this idea of there's a physicality to it. And again, if you imagined a straw, that distance 24 could not be straight up and down, because then we'd have some extra at the very bottom. So if you imagine swinging this way, what would happen is you would have 24 down there, which is bigger than 21, and then you don't have a real triangle. All sides are not connected. Nice. So again, that's this physical idea, and I do want to talk about that when I see you. But anyway, so here's that idea, the physicality of it. If the height is 21, then the only way I can make a triangle is to swing AB to the right. But I also want you to realize is you could swing AB to the left. So again, this is going to be our height. This is angle C. And again, angle C is 30. And this is 42. And we know the height is 21. But again, what we could imagine is we can imagine swinging this to the other side. And if we did that, what we would have is we would have this triangle right there. And that triangle would have this angle, and this side would be 24, just like the first one. And obviously, that's a different triangle. So that's what I want you to imagine. I want you to imagine, well, that's that side, and we swing it over until it touches. And when we do that, we get an obtuse triangle. We get a triangle with an angle greater than 90 degrees. So if I just redrew that picture now, then here's what it looks like. Here's C, here's B, here's A. We know this is 30, we know this is 42, and we know little c is 24. So again, just imagine, can I swing that side, little c, can I swing it down? Now, if little c was 21, we would have a right triangle, but it's greater. And we'll talk about more in class. So that's the general idea, the physicality of it. You don't need any complicated formulas. You don't need any complicated notations. All you need is a simple physical understanding, and it's all related to the vertical height. And then we compare our sides to that vertical height. As soon as we've done this, then we have our matching pair. So in this one right here, we want to solve. Now, I'm not going to go ahead and solve everything. I'm just going to figure out I'm going to figure out angle B. And again, if we figure out angle B, then we can figure out angle A, and then we can figure out little b. So in both of these examples, I don't care to solve. Normally when you see solve, it means figure everything out. But let's just make it a bit simpler, and let's just find the unknown, which would be angle B in both of these cases. So now, again, this is this idea. We've understood that we may have this weird case, and we have to go ahead and actually physically see if there can be more than one triangle. We don't have to worry about special occasions. We just have to ask ourselves the question. And in this case, we figured out the height. We looked at the height. We've looked at the other side, the little c, and we've just imagined what would that triangle look like. So we're going to go ahead and solve for b. And again, we're multiplying both sides by 42. And when we do that, we get 42 times the sine of 30 divided by 24. And when you punch that into your calculator, you get the sine of b is equal to 0.875. And again, in order to find angle b, we're going to take the inverse sine of our ratio, and we're going to get 61 degrees. So here's an example. Given this information, that one of the triangles could have angle B of 61, and if angle B was 61, then angle A would be 89. So if you want to continue on and do this, then make sure you check. So angle A would be equal to 89, and little a would be 48. So if you want to go on and do that, go ahead, pause the video, and just make sure it's right. Make sure you're right. And again, in this one right here, in order to do this one, we have our matching pair. But here's the problem. In this one right here, you would look at that and you would go, well, don't I have the same ratio? So if you looked at this one right here, let's actually just kind of play the devil's advocate. And this is what's important for you to realize. If we went ahead and went, okay, I want to figure out angle B. Well, in this one, we'd have the sine of C, which is 30, over the side opposite, which is equal to the sine of B over 42. And in looking at that, look at these two things over here, and don't they look exactly the same? And this is the problem. This is the ambiguity. They are exactly the same. But given that we can imagine this picture, it makes it really easy to figure out angle B, because angle B is simply equal to 180 degrees minus whatever we found out in case number 1. So angle B turns out to be 119 degrees. And again, if you want to go back and check this answer, again, if you're going, what? So again, the only reason, again, we know this idea of this swinging, this pendulum over, and if I know that this angle right here is 61, which it is, so that angle right there is 61, then we know that angles on a line add up to 180 degrees, and there you go. You could punch this back into here, and it would all work out. The left-hand side would equal the right-hand side. So obviously angle A changes as well. But here's this idea, this physicality, and that's what I want to focus on. So here's the question. If we have this example, I want to determine the values of side P that we get two solutions. So we want to figure out what could this side opposite 57 degrees be, so you actually got two triangles. Now again, there's kind of, when I mean two triangles, I mean a triangle like this. So here's one of them, like something like that. So here's your P, right? And little p would be over there, and q would be there, and this would be little q. So that would be something that a triangle could look like. And then the other side is, again, that q swinging over to the other side, and it could look like this. And again, what would I know? I'd know this, I'd know this, and I know this. And and what becomes important is the height of each of these. So in this one right here, this is what we want to draw, and we want to imagine little p, side little p, being able to swing. So let's work our way through. So I'm going to draw, here, I'll draw a bigger picture. So here's what we would have something like that, and we'd have something like that. And here's our angle P, and in this case, it's 57. And our little p is going to be over here. I'm just going to put a little something like that just to indicate that's where the side opposite big P is going to be. and Q is going to be down here, and little q is opposite 73.7. So there's three basic triangles I could draw. I could draw a right triangle, I could draw an acute triangle, or I could draw an obtuse triangle. And if the green line is too small, then I can't draw a triangle at all because angle P has to be 57 degrees. So the first thing we want to do is what actually determines how many triangles you can make is if I can figure out the height. And again, in figuring out the height, that's a perpendicular, that would be a right triangle. So if I want to make a triangle that has two different pictures, as I've drawn on the right, what has to happen is little p has to be bigger than h. If it's less than h, you don't have a triangle. It won't connect. And if it equals to h, then you'll only have one triangle, and that will be a right triangle. So it has to be bigger than h. So that becomes important to determine the values. That's why the height of this triangle is the most important thing. So let's go ahead and find the height. So the sine of 57 is equal to h over 73.7. H is equal to 73.7 sine 57. And when you figure out what h is equal to, it's 61.8. So here's what we know. We know that little p has to be bigger than 61.8. If it was equal to 61.8, we'd have a right triangle, and we'd only have one solution. But it has to be less than 73.7, because if it were bigger than 73.7, when we swing our pendulum over, it will be on that side. And again, we're only talking about these triangles to the right-hand side of P. So that's why any value in between 61.8 and 73.7, any value, I'll be able to make that triangle look like that. And when I imagine swinging it over, I get to there or wherever the case may be. This is the physicality. This is what I want to look at. Okay, so let's look at two examples. Check whether each triangle has one solution or two solutions, then solve. So again, it's important that you figure out the height and then go ahead and see if there are one solution or two solutions. And what you're going to see is you have to be careful. So let's quickly draw this picture. Here's my angle A. So again, my pictures all look the same. Here's my angle A, and here's B, and angle A is 41. And again, we're going to imagine the side over here is 12.3. We don't know exactly what it looks like, but I just want to illustrate the start of the line. And this one's 15.6. And all we're going to do is we're going to determine what the height would be of that triangle, and then we're going to make sure that we can have one or two solutions. So again, what I want you to notice is 12.3 is less than 15.6, so that's good. We're not going to be able to swing it on the other side of A, but let's see what we get. So again, we're just going to figure out the sine of 41 is equal to the height over 15.6, and the height is equal to 15.6 sine 41, which is equal to 10.2. And given that A is greater than 10.2, but it's less than 15.6, we're going to have two solutions. So again, that's really important. We're going to have two solutions, or we're going to think we have two solutions, and we're going to check it. So let's go ahead and solve the triangle. And I might do a couple of shortcuts for speed. So in in looking at this, here's this first picture. So the sine of b over 15.6 is equal to the sine of 41 over 12.3. So there's our matching pair. And again, we're going to multiply both sides by 15.6, and we're going to take the inverse sine of it. So I'm going to do all of that. And again, you should do it if you're not quite sure, but I'm not going to do it. I'm imagine multiplying, figuring out what the decimal is, pressing the button on my calculator, and I get 56.3. And if angle B is 56.3, then angle C is 82.7. So again, sum of angles in a triangle. And then if I wanted to figure out little c, what I could get is I'll just use the sine law again. And again, I'm not going to do all this work. We should have done enough work on our calculator to figure out what it is. And there I get 18.6. So that's case number 1. But we also have case number 2, which looks like that. And again, we still have 12.3, and we still have 15.6, and we still have 41, but now this is the supplementary angle to 56.3. So this one right here tells us angle B is equal to 180 minus 56.3, which is equal to 123.7. And if angle B is 123.7 and angle A is 41, then angle C is equal to 15.3. And then when we do our sine law again for this one, again, I'm just going to enter it. You could use your calculator to double check this, but we get A is equal to 4.9. A is equal to 4.9. And again, when you look at the picture, that makes sense. Sorry, little c. This is little c. That should make sense because angle C is the smallest, therefore little c should be the smallest side. Okay, so again, key idea. Draw the picture, figure out the height, imagine what could happen. Swing this line over. Can you do that? Will it make another triangle? So let's look at our last example. And again, we're going to draw our picture. We're going to imagine this. Here's our angle B right here. We have C, so there's our angle C over here. And that's 39 degrees. And little b again is 14. And little c is 10. So here's what I want you to see right now. Given that the blue line, I'm not drawing the blue line right now, that blue line is way bigger than 10. If we extended this blue line, when you swing this one over, you're going to be on the other side of B, and that is not possible, or that's not allowed. But I'm going to show you that in a different way, but again, physically, that's our idea. So first thing we want to do is we want to figure out the height, because again, if that blue line is equal to h, we only have one triangle. So sine of 39 is equal to h on 10. H is equal to 10 sine 39. H is equal to 6.3. Okay, so that's great. The height is 6.3. Therefore, this picture that I just drew, that's what it's going to look like. And as we just discovered, that's the only triangle that you can draw. Okay, so given that we're going to go ahead and find C now, because we have our matching pair and we have a piece of information. So we want to know C, angle C. So we're going to have sine C over little c is equal to sine 39 over 14. And we're going to multiply both sides by 10. Sine C is equal to 10 sine 39 over 14. The sine of C is equal to whatever. So I'll erase that. And when you figure out what that is equal and you do the inverse trig function, angle C is equal to 26.7. And angle A would be equal to 114.3. And again, that's simple sum of angles. And if you want to use the sine law again, to figure out little a, go ahead and make sure you get that. It's valuable. But here's what we said before when I said swing the 14 over. When you swing the 14 over, you're on the left-hand side of B, and that's not allowed. And if we use our supplementary angles, so if we thought there was going to be another solution, then angle C of our other solution would be 180 minus 26.7, which would equal 153.7. But what I want you to recognize is this is impossible. And here's why. We already know angle B is equal to 39. And if angle C is equal to 153.7, well, the sum of those two angles is 192.7, which is way too many. We only have 180 degrees in the interior of a triangle, and we've only used two sides. So again, the most important part of the ambiguous case is sketching a picture, figuring out that height, and then looking at the story and just thinking